This video is on solving equations for a specific variable. Sometimes it is helpful to have an equation with more than one variable be solved for one of the variables in terms of the others. For example, the equation 3x plus 2y equals 16 can be written as x equals negative 2y plus 16 all over 3. The second equation is solved for x in terms of y. In order to solve for a specific variable, we want to use the order of operations in reverse to isolate the desired variable. We're going to undo in reverse order anything that was done to the variable. So for example, in the equation 3x plus 2y equals 16, x is being multiplied by 3, then it's having 2y added to it. So to solve for x, we're going to undo that in reverse order. I'm going to subtract 2y, and then I'm going to divide by 3. So let's take a look at how that would look. So if I want to do that, I'm going to do a minus 2y first on both sides. Those will cancel out. It leaves me with 3x equals 16 minus 2y. And then to isolate x, I'll divide both sides by 3. So my final answer is x equals 16 minus 2y over 3. This is the same equation rewritten in terms, it's solved for x in terms of y. So here I have three examples, three equations that I'd like you to try on your own. So if you would stop the video right now, copy these three equations in your math journal and solve for the specified variable. Okay, let's take a look at how we're going to solve these. So the first one says solve 3n plus 6p equals 15 for n. So I want my final answer to be n equals everything else. So I need to undo what was done to 3n. I'm sorry, what was done to n. So n is being multiplied by 3, and then it's having 6p added to it. So the first thing I want to do is subtract 6p on both sides. And those will cancel out. That gives me 3n equals 15 minus 6p. Be sure to keep that minus or that negative in front of the 6. And then I'll divide both sides by 3. And that's going to give me n equals 15 minus 6p over 3. But I noticed something interesting about this, that both 15 and 6 can be divided by 3. So actually I could rewrite this as 15 over 3 minus 6p over 3. And 15 over 3 will reduce to 5. And 6p over 3 will reduce to 2p. So actually I could write as my final answer n equals 5 minus 2p, and that would be the most simplified form. Our second example says solve k minus 2 over 5 equals 11j for k. So I want to get k all by itself. Notice that k is having 2 subtracted from it, and then it's being divided by 5. So I want to undo that backwards. I'm going to rewrite the equation over here so I can actually show some things. Okay, so since it's being divided by 5, I want to multiply both sides by 5. So these 5's will cancel, and it leaves me with k minus 2 equals 11j times 5, which is 55j. And then I will add 2 to both sides. And that's going to give me, I'll go ahead and write it up here, that k equals 55j plus 2. So this is the equation solved for k in terms of j. And my last one says solve a times the quantity b minus 8 equals 17 for b. Now your first thought might be, oh, I see parentheses, so maybe I want to distribute. But actually that's not the easiest thing to do here, since I want to get b all by itself. Notice that b is being subtracted by 8, and then the whole thing is being multiplied by a. So the first thing I think I'll do is multiply both sides by a, and those will cancel out. And that's going to give me b minus 8 equals 17 over a. And I would strongly encourage you to use a horizontal fraction bar. Don't use a slanted or a diagonal fraction bar. And the reason is, now when I go to add 8 to both sides and I write my final answer, I want to make sure that 17 is in the numerator, a is in the denominator, and 8 is a whole number that's being added to it. So that would be my final answer. So in this video, we took a look at how to solve an equation for a specific variable. You need to identify what variable you're solving for and undo in the reverse order whatever was done to that variable.